We will move on to discuss the behavior of the oxides of elements from sodium to chlorine in water. When we talk about the behavior of the oxides in water, we have two focuses. 1. Is the oxide soluble in water? Is there any reaction between the oxide and water? 2. If the oxide reacts with water, is the product acidic or alkaline? In general, if there is a reaction between the oxide and water, metal oxide, which is ionic oxide, reacts with water to give metal hydroxide, making the solution alkaline. For example, sodium oxide reacts with water to give alkaline sodium hydroxide solution. Nonmetal oxide, which is covalent oxide, reacts with water to give acid, making the solution acidic. For example, sulfur dioxide reacts with water to give sulfurous acid solution. For the three metal oxides, sodium oxide is soluble in water and also reacts with water to give sodium hydroxide. Sodium hydroxide is alkaline. Magnesium oxide is only slightly soluble in water and it reacts with water to give magnesium hydroxide. Magnesium hydroxide dissociates in water slightly to give an alkaline solution. Aluminum oxide is insoluble in water, also does not react with water, and water remains neutral. For the four nonmetal oxides, silicon dioxide is insoluble in water due to its giant covalent structure. Also, it does not react with water, and water remains neutral. Phosphorus pentoxide is soluble in water and also reacts with water to give phosphoric acid, H3PO4. Phosphoric acid is a weak acid and the resultant solution is acidic. Sulfur dioxide is soluble in water and also reacts with water to give sulfurous acid, H2SO3. Sulfurous acid is a weak acid and the resultant solution is acidic. Dichlorine monoxide is soluble in water and also reacts with water to give hypochlorous acid, HOCl. Hypochlorous acid is a weak acid and the resultant solution is acidic. Note that the oxidation number of elements remains unchanged, and so redox reaction is not involved. For example, the oxidation number of phosphorus is +5 in both phosphorus pentoxide and phosphoric acid. You can check the oxidation number to make sure you are not mixing up the formula with that of other acids. For example, the oxidation number of phosphorus is +3 in phosphorus acid. It is not formed when phosphorus pentoxide reacts with water. This is because the oxidation number of phosphorus should remains as 5 when phosphorus pentoxide reacts with water. This rule holds for other oxides introduced in this chapter. Sulfur dioxide reacts with water to give sulfurous acid, but not sulfuric acid because the oxidation number of sulfur should remains as +4. The oxidation number of sulfur in sulfuric acid is +6. Dichlorine monoxide reacts with water to give hypochlorous acid, but not hydrochloric acid, because the oxidation number of chlorine should remains as +1. The oxidation number of chlorine in hydrochloric acid is -1.